Hello, welcome to how to solve these equations for x and y. Cube root of x plus cube root of y is equal to 13 and square root of x plus square root of y is equal to 35, where x and y are positive integers. We notice that here we have cube root of x and here we have square root of x, and here we have cube root of y and here we have square root of y, and the smallest number that is divisible by both 3 and 2 is 6. So we suppose that let x is equal to a to the power 6 and y is equal to b to the power 6. So we replace the x with a to the power 6 and we replace the y with b to the power 6. Then this equation becomes cube root of a to the power 6 plus cube root of b to the power 6 is equal to 13, and this equation becomes square root of a to the power 6 plus square root of b to the power 6 is equal to 35. Next, we can write this cube root of a to the power 6 in exponential form as a to the power 6 over 3 plus, and we can write this cube root of b to the power 6 in exponential form as b to the power 6 over 3 is equal to 13, and we can write this square root of a to the power 6 in exponential form as a to the power 6 over 2 plus, and we can write this square root of b to the power 6 in exponential form as b to the power 6 over 2 is equal to 35. Next, this equation becomes a square plus b square is equal to 13. We name this equation equation 1, and this equation becomes a cube plus b cube is equal to 35. We name this equation equation 2. Next, according to an algebraic identity, a cube plus b cube is equal to a plus b times a square minus ab plus b square is equal to, and this 35 can be factorized as 1 times 35, 5 times 7, 7 times 5, and 35 times 1. We have 4 cases here, and if a and b are two positive integers, then a plus b is always smaller than or equal to a square minus ab plus b square. So these two cases, 7 times 5 and 35 times 1, will be rejected because 7 is greater than 5 and 35 is greater than 1, and a plus b cannot be greater than a square minus ab plus b square. And if a and b are two positive integers, then a plus b cannot be equal to 1. So we reject this case also 1 times 35 because a plus b cannot be equal to 1. The only case left is 5 times 7. So we factorize this 35 as 5 times 7, and from here this a plus b is equal to 5, and this a square minus ab plus b square is equal to this 7. A plus b is equal to 5, and a square minus ab plus b square is equal to 7. We name this equation equation 3 and this equation equation 4. Next, we can find the value of AB from this equation 4. We can write this equation as a square plus b square minus ab is equal to 7. Next, here we put the value of a square plus b square from equation 1, 13. The value of a square plus b square is 13 minus ab is equal to 7, and we move this minus ab to the right side and this 7 to the left side. ab is equal to 13 minus 7, and ab is equal to 6. Now to find the values of a and b, we need to find the value of a minus b, and to find the value of a minus b we use an algebraic identity, that is a minus b whole square is equal to a square plus b square minus 2ab. Next, a minus b whole square is equal to, we put here the value of a square plus b square, 13 from equation 1. The value of a square plus b square is 13 minus 2 times, here we put the value of ab from here 6, 2 times 6. Next, a minus b whole square is equal to 13 minus 12 is 1, and if we take a square root of both sides, then this implies a minus b is equal to plus minus 1. It means a minus b is equal to 1 and a minus b is equal to negative 1. We name this equation equation 5 and this equation equation 6. Now to find the values of a and b, we add these two equations, equation 3 and equation 5. In equation 5 we add equation 3, that is a plus b is equal to 5. This is equation 3, and we add these two equations, 1a plus 1a, 2a, and this negative b will be cancelled with this positive b, is equal to 1 plus 5, 6. And if we divide both sides by 2, we get the value of a 3. And if we put this value of a 3 in equation 3, we get the value of b 2. Now we add this equation 3 in equation 6. Equation 3 is a plus b is equal to 5, and we add these two equations, 1a plus 1a, 2a, and this negative b will be cancelled with this positive b, is equal to 5 minus 1, 4. And if we divide both sides by 2, we get the value of a is equal to 2. And if we put this value of a2 in this equation 3, we get the value of b is equal to 3. Now from here, if we take power 6 of both sides, we get a to the power 6 is equal to 3 to the power 6, and a to the power 6 is equal to 729. And if we take power 6 of both sides from here, we get b to the power 6 is equal to 2 to the power 6, and b to the power 6 is equal to 64. And from here, a to the power 6 is equal to 64, and from here b to the power 6 is equal to 729. Now recall that we have supposed x is equal to a to the power 6 and y is equal to b to the power 6. We have supposed x is equal to a to the power 6 and y is equal to b to the power 6. So from here, x is equal to a to the power 6 is 729, and from here y is equal to b to the power 6 is 64, y is equal to 64, and from here x is equal to a to the power 6 is 64, and from here y is equal to b to the power 6 is 729. So we have these two sets of solutions, x comma y is equal to 729 and 64, and 64 and 729.